Okay, let's take a stab at trying to finish this video. All right, so what do we find? That when we took the derivative and set it equal to 0, we're hoping that our max and our min pop up. So we got 3 points that we're hoping are max, min, or something. Okay, so notice when you take your derivative, set it equal to 0, you should have 0 slope on your original function. Here, 0 slope here as well at your maximum as well as your minimum. All right, so let's try to figure out what that is. I'm going to create a number line, and I'm going to use what's called the first derivative test. All right, at the bottom, I'm going to put f prime, and I'm going to try to see if that can tell me what f looks like. All right, I'm going to put these numbers right on here. So -1, that'll be 1. Let's do 0 here. And then also we like to check what happens at 2. All right, so you'll notice once we've identified our critical points, this one and this one, your function is consistently decreasing up to the critical point, and here consistently increasing to the next critical point, and then consistently decreasing thereafter. So your function should be behaving exactly the same between critical points. So right here where we would expect there to be a max or a min or something, and there max min or something, there max min or something, in between these points we would expect the exact same behavior. All right, so I'm going to pick a random number to the left of -1. How about -2? And I'm putting that in quotation marks because I could have chosen -75 or -1.5 or -7. Okay, I'm just happening to choose -2. Here between -1 and 0, what I do, -1/2 as my test point. Any of the numbers in there would have worked. And here between 0 and 2, let's just pick 1. It doesn't have to be halfway in between. And then over here past the 2, why don't we just pick 3? Okay, what I'm going to do is you'll notice that the label right here is f prime. And the reason that it's f prime is because I'm going to use what's called the first derivative test. I'm going to plug all of this information back into my first derivative. Okay, so I'm going to go back up here and I say, what was the first derivative? Here's one version of it. Of course, you could use any of the versions that follow, right? Even this one, 12x times x minus 2 times x plus 1. That would work as well. Okay, so let's see. I'm going to do f prime of my first x value, and then I'll do f prime of my next test value, -1/2, and then I'll do f prime at my next test value, which is 1, and then I'll do f prime at 3. Okay, so let me go back up here to remind myself what f prime is. There is a fast way of evaluating all of these derivatives on your calculator. So why don't we briefly do that? Okay, all you have to do, go to your y equals, you want to delete that out, oops, clear that out, and you're just going to plug in the function that you'd like to evaluate. So 12x raised to the 3rd power minus 12x squared minus 24x. Now, regardless of whether I can see this or not, I should still be able to evaluate it, as long as my x's are in the window that I've given. All right, so let me see what I'm trying to do. I'm trying to evaluate at x equals -2, so I'll do second calc, number 1, and just plug -2 in. See what the calculator finds. So if you can see that, it reads at x equals 2, you get a y value of -96. In this case, you get f prime equals -96. So this is -96. Okay, you can do that for the rest of them. I'm going to do that now real quick. -0.5. Oh, -0.5. Here I get positive 7.5. Second calc. Here I get -24. Second calc. And positive 144. So just in case you're curious, I'm going to do this very first one so that you can follow along. Notice this is the function that I'm using where my finger is right here. This is equal to 12 times negative 2 cubed minus 12 times negative 2 squared minus 24 times negative 2. This is what equals negative 96. All right, so let me go back up here. When I plugged negative 2 into my derivative equation, it spit out a negative 96 value. Okay, so when I plugged in negative a half right here into my derivative equation right up here, right, this stuff is not random, it spit out a positive 7.5. When I put 1 into my derivative equation right up here, it spit out a negative 24. Notice what I'm doing, negative here. I don't care about the number itself, I just care about the sign. And then finally, when I plug 3 into my derivative equation, I get positive 144. So let me go back up here because I really need to start thinking about what that means. If your derivative is negative, it tells you that your original function, let's go over here and see what it says. Look at that. If your derivative is negative, your original function should be decreasing, should be coming down. So notice I'm going to sketch that on here. My derivative is negative, my function has to be coming down. Okay, let's move on, which means the same thing's going to happen here. So this one says my derivative is positive. Let's look over here. If my derivative is positive, that indicates that my function is increasing. So if the slope of my tangent line is positive, my function should be increasing. Notice this is your function, so you're going back to that. There you go. And there you go. In both of those cases, you have positive slopes. All right, so now what I can say quite quickly is if I'm trying to see what f of x looks like, this looks like a local min right here at x equals negative 1. There's a local min right here at x equals 2, and a local max right there at x equals 0. So that's how you would use your first derivative test in order to tell you what your original function looks like. Okay, this does take some practice, so I would urge you to do the problems that I have assigned. Please only do the first 5 problems. So what I've asked you to do is what you see in your notes. Okay, so notice I did that problem in its entirety right here. Right, so if you go down, you should see exactly what I just said on that entire page. So you should be able to duplicate that. And then on the page that follows, I give you 10 problems, but only 5 of them really are readable. So I want you to do that exact same process for the first 5 problems. What are you going to do? You're going to look for max mins. Take the derivative. Set the derivative equal to 0. Solve for your variable. And then once you find those points, you need to use your first derivative test.